explain it. Alright, so we are going to graph a quadratic function, meaning that it's going to be a parabola. We're going to graph one of them here. If you can do one, you can do them all. You just have to follow these steps. Alright, so let's see here. We're going to start out with the, whoops, I need a pen, I guess. With the function y equals, we're going to go with negative 3 x squared plus 6x, can I squeeze it in here, plus 5. Alright, and you're going to see that I'm going to be doing some writing and erasing in order to fit everything on here. So you could always pause or go back if you were interested in seeing what I had erased. Alright, so the first thing that we need to do in order to graph this quadratic function is to find an axis of symmetry. So let's write that down here. The axis of symmetry is a line. It's going to be a vertical line that we could fold the parabola over, and it's like a mirror image of itself over top of that line. So in order to do this, we're going to use the following formula. We're going to say x is equal to negative 1/2 b divided by a. Alright, now we have to know what b and a are in order to do this, so this is where I'm going to point some things out to you here. Whenever you have a quadratic function, the letter a is this number right here in front of the x squared. So negative 3 is our a. The letter b is always going to be in front of the x. Okay, so 6 is our b. And the letter c is always a constant. Okay, so 5 is our letter c. So if I want to find my axis of symmetry, I'm going to fill in 6 for b and negative 3 for a, just like that. And now I'm going to do a little math. Multiply straight across. We have negative 6 over negative 6, and that tells us that our axis of symmetry is x equals 1. Now, when I go to graph this, to graph any line where it's x equals some number, it's always going to be a vertical line, and in this case it's going to go through 1 on the x-axis. So I'm going to make it a dotted line just to show that it's not really part of our parabola, it's just something that we can use to help graph the parabola, and it's something that all parabolas have, although they may not be shown to you on the graph where exactly that axis is, but we're going to use it here to graph ours, so we'll keep it around. Alright, so anyways, our axis of symmetry is x equals 1, and off to the side here I'm going to write this, since I'm going to do some erasing, just to remind myself that that's what it was, or I could look over here and see that it's x equals 1. Alright, the second thing that we want to find, let's see if I can make this eraser bigger. I can, good. Alright, the second thing I want to find besides the axis of symmetry is the y-intercept. So for my y-intercept, what I'm going to do is plug in 0 for x and see what pops out for y. And we can do this without actually plugging it in. We can just take a look at our function right here. If I put a 0 in right in this first term, I'm going to have 0 squared, which is 0 times negative 3. That's 0. If I put a 0 in with that x right there, 6 times 0 is 0. So that term's gone, and I'm left with this 5, this c. It's always going to be that way when you plug in 0 for x. So when you find your y-intercept, it's always going to be 0 as the x-coordinate. And this is always going to be the letter c from your function. So 0, 5 is our y-intercept. And then we can go ahead and graph this. So let's do that here. 0, 5. Going to put a dot right there. That's our y-intercept. Now, if you look here, the axis of symmetry is going to help us out. If I look and see how many spaces away from the axis of symmetry that point is, it's just one space right there, one space. So I can actually go over one space on the right, and I can put another dot, because this dot will reflect across that axis of symmetry right to there if I were to fold it like it was a piece of paper. So now we have two ordered pairs, or 2 points, on our graph. Alright. There's 2 more things that we're going to do here, and then we will be done graphing. The next thing I want to do is to find my vertex, which is either the very top or the very bottom of my graph, the max or the min. Okay, now I can look at the coefficient, the letter A right here, this -3 of my x squared term. Since it's negative, I know that my parabola should open upside down, and that tells me that my vertex is going to be a max. So let's go ahead and figure out our vertex, and here's how we'll do it. We're going to take our function, and we're going to plug in this number, this 1 that we got earlier in the problem. Whatever number you get there for the axis of symmetry, you're plugging that in for x. So we'll do that right here. And let's see what pops out for y. Well, we have -3 times 1, I just squared the 1, plus 6, plus 5. And this results in -3 plus 6 plus 5, which gives us 8. So our vertex, the ordered pair for our vertex, is 1, 8. And I can put it on the graph. 1, 8 is right there. That's going to be the highest point on our graph, and it's going to lay right there on that axis of symmetry. Alright, we have one more thing to do here, one more point to find, and that is to get an extra point so that our graph is a little more accurate since we're drawing it by hand. So we'll just say this is an extra point. And at this point you can fill in anything you want. You can pick any x value that we haven't used already. Now we can't use x equals 0 because if you see, if I go up from x equals 0, I run into a dot. Can't use 1 because I go up, run into a dot. If I try to use 2, I run into a dot. So 3's fair game, 2.5's fair game if you want, although I don't want to mess with those decimals. But 3, 4, 5, 6, 7, 8, 9, 10, or you can use like -1, -2, whatever. You can plug it in and figure this out. So I see that -1 is open. I'm going to use that. So let's take our function and let's fill in -1 everywhere I see an x. And let's figure out what pops out for y. So I have -3 times 1, because -1 squared is 1, right? I have -6 and plus 5. That'll give me -3 minus 6 plus 5. And we see that we get -9 plus 5, which is -4. So the ordered pair that goes with that would be -1, because that's what I plugged in, and -4 popped out. So I would use that ordered pair, and I want to put it on my graph. -1, whoops, -4. Now, because I did that, I can now reflect this point across the axis of symmetry, count over 1, 2, so then I have to go 1, 2, and you'll see that, you know, the axis of symmetry is right in the middle of those 2 points. That's what I wanted. So I'm done with all that. That's everything that I needed there, and the very last thing I need to do is just go ahead and draw my parabola. It's kind of ugly doing it by hand, but you guys get the idea. Alright, so that's it. That's how I'd expect you to graph a quadratic function.